So we're going to work on a topic that you know a little bit about already, solving radical equations. So we did this with square roots. So to undo a square root, we have to square both sides. I have that filled in already here. And when we're getting rid of a cube root, we have to now cube both sides because a cube and a cube root are inverse operations. You have to make sure too that you always get the radical by itself. So you want to isolate that. And sometimes when you solve, you're going to get two different values. Both of the values might not work. You might have an extraneous solution. So when you solve it, you get an answer, but it actually does not work for the equation. So you want to make sure you check each solution. So let's get started here. I'm going to pause it too so that you don't have to watch me solving it. It just goes a little bit faster. So 2 root x plus 7 equals 11. So the first thing we're going to do is isolate that radical. So go ahead, everyone, and subtract 7, divide by 2, and let's go to that spot. So hopefully we all have root x equals 2. So now we're going to square both sides here. Change that to a different color so you can see it a little bit better. And then we're going to go and get x equals 4. So now what we're going to do is we're going to check that. Does it work? So 2 times the square root of 4, that would be 4, plus 7 equals 11, so it works. The answer there in curly braces. Now for this next one here, we're going to first go ahead and square both sides, and we do have an expression here, so we're going to put parentheses around that, and then this product of x and root 2, we'll put a parenthesis around that too. So when we square both sides, this becomes x squared plus 2x plus 1. It's a perfect square trinomial, and it equals, it'll be x squared, and then root 2 squared is 2. I'm going to bring all my terms over to the right-hand side. So this is 2x squared, so I'm going to subtract that x squared, giving me positive x squared, and then it'll be a minus 2x, and then a minus 1 equals 0. So from here, you can use quadratic formula or complete the square, but everyone go ahead and solve for x. So hope you all got x could either be 1 plus root 2 or x could be 1 minus root 2. So I'm going to go ahead and check it. On the left-hand side, if I have 1 plus root 2 and I'm adding 1 to it, I get 2 plus root 2. And on the right-hand side, I have to multiply that 1 by root 2 by root 2. So I'm going to do root 2 times 1 plus root 2. And I get root 2 plus 2. So this works. Now the next one, I'm going to add 1 to it, and I get 2 minus root 2. And right away, hopefully you notice, if you were to distribute this root 2 times 1 minus root 2, you're going to get root 2 minus 2, which is not the same as 2 minus root 2. So this isn't extraneous. So the only solution that works here is our 1, can't really see it that well, but 1 plus root 2 would be our solution. So number 3, when we isolate the radical, we have to subtract that 9. So you have a root, square root, equal to a negative 8. Because you have a square root equal to a negative, there's no solution. But you want to be careful because now we're working with things besides just square roots. And if it were the third root equal to a negative, you will have a solution. So the last one here, problem 4. When you square both sides here, you want to make sure you put parentheses around that expression. So we'll square both sides, and that will leave us with x minus 16 equals 4 minus 4 root x, and then plus square root of x squared is just x. Now from here, we're going to bring everything, combine it. Notice we have that positive x on both sides, so those would become a 0. I'm going to subtract 4, so I get negative 20, and it equals negative 4 root x. Divide by negative 4, I get 5 equals root x. So if I want to solve that from there, I'm just going to square both sides. And I get x is equal to 25. Let's do a quick check. 25 minus 16 is 9. Square root of 9 is 3. And then 2 minus the square root of 25. Well, 2 minus the square root of 25 would be a negative 3. So that would not work. So therefore, we have another one that is a no solution. I'm just going to do the empty curly braces, or pretend they're curly braces, instead of writing that up. So no answer works for this problem here. So for the next 6 problems, what I want to do is just isolate the radicals for each of these. So everyone just go ahead and isolate the radicals. We'll look at solving them after we do that. I'm just going to do the first 2 with you. This is our radical there, that 1/3, if you remember from our previous section. So just keep going, isolate the radical for the next 4. We didn't need to isolate the radical for number 9 because that was already alone, but everything else needed to be done. So for 5, moving back here, we have a third root. So to get rid of the third root, again, get rid of a third root, we have to cube both sides. So we're going to go ahead and cube both sides. So from there, out comes the radicand, 4a minus 1, and it equals 27. So then you add 1, you get 28, divide by 4, leaving us with a equals 7. We can check that to see if it works or not. 28 minus 1 is 27. Third root is 3. 3 minus 3 is 0. Next one, just displayed a little differently. 1/3 power means the third root. So how do I get rid of that? I'm going to change back the color. Cube both sides. And it is okay. We have a third root equal to a negative. You can have cube roots that are negative. We get 3x plus 1 equals a negative 125. So we'll subtract 1, we get negative 126, and then divide by 3, giving us x equals negative 42. And we can go ahead and check that and see if that works or not. 7 has a 4th root. So what do you think? How do we undo a 4th root? We're going to take both sides and raise them both to the 4th power. So we get 2x plus 6 equals 16. Subtract 6, divide by 2, we get x equals 5. And we can go ahead and check that. 10 plus 6, 16. 4th root is 2. Multiply that by 3 is 6, and then subtract 6 is 0. Right. How do we get rid of a 6th root? We're going to raise each side to the 6th power. I totally forgot. This should not be a 14. I was thinking to myself, why would we do that to you? That should be a 2 there. All right, so we get 5y plus 4. And 2 to the 6th power is a lot more reasonable. We get 64. Subtract 4, divide by 5, so y is 12. And we can check that. That one does work. For the next one, we're going to square both sides. So I'm going to square this side, and I'm going to do the same to this, but put it in parentheses so you make sure you do your x plus 2 quantity squared. So we get x squared minus 8 equals x squared plus 4x plus 4. Bring all your terms to one side. Their x to the 2nd power will cancel out. So I'm going to subtract that 4 and change to black ink here. So we get negative 12 equals 4x. So x is negative 3. So when I check that, 9 minus 8 is 1. So we get the square root of 1. And then here we get negative 3 plus 2. So negative 3 plus 2 is 1, and the square root of 1 is 1. Those are not equal. So for number 9, we actually have no solution. X equals negative 3 is an extraneous solution. Now this last one here, we have isolated one radical, so you're going to square both sides again. Put those parentheses around the expression. So we get x plus 8 equals 9 minus 6 root x plus 35 plus the radicand comes out now, x plus 35. So go ahead and clean that up, and we're going to get that 6 root 6 by itself. I'm not sure if I misspoke a second ago, but it should be negative 6 root x plus 35. That's what we're trying to get alone. So I did that, and then I divided by that negative 6 to get my radical isolated again. So here I'm going to square both sides. We have to get rid of that second radical. So we get 36 equals x plus 35. And lo and behold, x is equal to 1. Check if it works. We get 3 minus 6. 3 minus 6 is negative 3, so our solution here is 1. Hope you understand how to solve not just your square roots now, but your cube roots, your fourth roots.